Hey, what's up, Chem Peeps? What in the heck are we gonna do in this video? We are going to describe precipitation reactions. As always, breaking it down. Not much to do here. We're just gonna use a list of solubility rules to predict whether a precipitate will form when the solutions of soluble ionic compounds are combined. Alright, so let's first define what the heck a precipitation reaction is. It's simply a reaction in which aqueous ions in separate solutions are mixed together to form an insoluble compound that settles out of the solution as a solid. The insoluble compound that settles out is called a precipitate, hence precipitation reactions. In other words, precipitate is a fancy name for the insoluble compound or the solid that forms. Let's take a look at an example precipitation reaction. I'm going to mix together some aqueous sodium chloride and some aqueous silver nitrate. When we mix these two solutions together, we're going to form a precipitate, an insoluble product. At the molecular level, you'll see some of those ions come together and settle out of solution as a solid or a precipitate. And at the macroscopic level, you're just going to see this solid form at the bottom of your beaker or your flask. Now, importantly for this video, you want to be comfortable using a reference chart of solubility rules to determine which compounds will form precipitates, which things will be insoluble in solution. And lucky for you, you've got a handy dandy solubility rule chart in the front of each of your booklets on your formula chart for you to use at any time. Notice that you're given a list of ions that when found in compounds will mean that those compounds are generally soluble, and you're given a list of ions that when found in a compound, those compounds will be generally insoluble. Alright, so we've talked a little about what precipitation reactions are. Now let's take a closer look at how we can predict the products in a precipitation reaction. Use the following steps. 1. Determine what ions each aqueous reactant has. Let's come back to this example in which we mix an aqueous solution of sodium chloride and an aqueous solution of silver nitrate together. Let's think about what ions are in each of the solutions. In the sodium chloride solution, we've got sodium ions and chloride ions. In the silver nitrate solution, we've got silver ions and nitrate ions. So that's your first step. Just think about what ions are in each of the aqueous solutions that you're starting with. Step number 2. Determine formulas of possible products by exchanging ions. Remember, precipitation reactions are double replacement reactions. They're just going to switch partners. Remember that the positive ion or cation from one reactant is going to hook up with the negative ion or anion from the other. So let's come back to this example. When I mix these two solutions together, the sodium ion from my sodium chloride solution could potentially hook up with the nitrate ion from my silver nitrate solution. And the silver ion from my silver nitrate solution could hook up with the chloride ion from my sodium chloride solution. Step number 3. Determine the solubility of each product in water by using that handy dandy solubility rules reference chart. And then the question becomes, which one of these things is going to form an insoluble solid, an insoluble precipitate, and precipitate out of solution? That's where this handy dandy list of solubility rules will help you out. Take a look at this first potential compound that could form, sodium nitrate. As I scan my solubility rules, notice that sodium ions are highly soluble. In fact, it doesn't matter what the sodium is paired with, it's always going to be soluble. There are no exceptions. Additionally, let's say you found the nitrate ion first. Nitrate salts are also highly soluble, and there are no exceptions. So this compound, sodium nitrate, is going to stay floating around in solution as ions. Now let's think about the solubility of this potential compound, silver chloride. As I scan my list, here's the chloride ion. Salts containing the chloride ion are typically soluble. However, when the chloride ion is paired with silver ion, the resulting compound is insoluble. So my solid precipitate that forms is going to be silver chloride. Let's take a look at these two aqueous solutions one more time. When I mix the two together, notice what happens. At the molecular level, you can see the chloride ions coming together with the silver ions and precipitating out as silver chloride, your insoluble product. Notice that the sodium ions and the nitrate ions stay dissolved in solution as soluble aqueous ions. Brings us to step number 4. If any of the possible products are insoluble, write their formulas as the products of the reaction using a S in parentheses after the formula to indicate solid. Any soluble products, write the letters AQ in parentheses after the formula to indicate aqueous. Then finally, step number 5. Don't forget to balance the equation. Remember to only change coefficients and not subscripts when you're working to balance the equation. My initial reactants are sodium chloride, which is aqueous, and I react it with silver nitrate, also aqueous. On the product side though, I'm going to designate my sodium nitrate as aqueous, but my silver chloride as a precipitate by including the letter S in parentheses after writing its formula. And again, I want to make sure that this is balanced, and lucky for us, it is balanced, with coefficients of 1 for each of the reactants and products. Finally, before we finish, step number 6. If neither product will precipitate, which happens sometimes, write no reaction after the arrow in the equation. As an example, I'm going to mix together a solution of sodium chloride and potassium hydroxide. Notice in this instance, when I mix the two solutions together, I'm not going to form any solid precipitate. All of the ions involved are going to stay as aqueous soluble ions in solution. Alright, and that does it for this video. Have a fantastic day.